Concordance, I'm going to throw this open to you. What effect do you think that Sandy will have on the outcome of the election, given that normally in times of crisis and disaster such as Sandy, the incumbent seems to be the one that benefits?
You know, I think the most significant impact is Chris Christie, the New Jersey governor, and his praise for how Obama handled the crisis. You know, everyone always thinks, and this has always been the case, that the incumbent has the advantage because in times of the actual exercise of authority, they have all that advantage. They have that national stage. They have the power of the office, which can also be used for campaigning. And I'm just going to go with the conspiracy theorists to say that, you know, all of Sandy was probably a plot by Obama using the HAARP, high altitude, whatever, AARP, up in Juneau, Alaska, that's probably what started Sandy. So if we're going to talk about the physics or the science behind what caused Hurricane Sandy, I think it's pretty obvious that
there have got to have been
aliens,
termites involved somewhere. But I think that he actually made it happen 2 days too early, because there are still people, or there are people beginning now to complain that not enough is being done. So I think that if he had plotted it, he got it slightly out of sync. He should have done it a couple of days later. Thunderfoot, what are your views?
I mean, to me, I always thought the hurricane season was earlier than this. And this seems to be true, because normally hurricanes are when there's lots of heat in the Atlantic. That's what gets them going. So this is very late for a hurricane. It's also fairly rare that they go up as far as New York. Normally you expect them in the Florida and Gulf area. I mean, when was the last
drawn
time?
in by the jet stream, Thunder. The jet stream dipped very far south, which actually sort of stirred up a low pressure front and guided it towards that higher pressure cold air. But I mean, that's actually what made Sandy so scary. Was you've got basically a winter storm sitting over the midpoint of the continent. The jet stream down as far south as I have seen it in a long time, and that helped to move everything north without sort of hitting the usual spots along Louisiana and Florida. And you're right, this isn't the usual season. It's late in the season, but generally fall and spring are very broad categories where you can have them happen.
What I thought was interesting was the degree of accuracy with which they could predict its movement.
Well, a lot of that is just the simple macroscopics of the air pressure. Yeah, so what dictates the way these things move. But the details are always incredibly fiddly, because the weather is an emergent pattern, which, as someone who has lived in England, and you have as well, DPR, for a long time, the one thing that you learn is the temperate maritime climate is inherently unpredictable. So
tell Michael Fish that.
Yeah.
Just so, for those that obviously the majority don't understand that reference, Michael Fish was a weatherman on the BBC who, 20 years or more ago, classically went on to live broadcast of his forecast, and said that there had been reports that there was going to be a hurricane hitting the south of England, and these reports were absolute nonsense, and it wasn't going to happen. Within about 12 hours, the entire south of the country was absolutely obliterated. As you say,
obliterated. I mean, we might have had 1 or 2 deaths, but I mean, it's nothing like this one. I mean, this one, what's the death toll at the moment? It's about
185. 185.
Is that American deaths?
That's total. Yeah, the only ones that matter, of course, for the American deaths.
Well, this is the point, obviously, I wanted to raise, because whilst Sandy was developing further south, it killed quite a few people in other countries. And none of that was reported. It's only when American citizens die that it becomes newsworthy. Now, what's that about?
Well, I'm sure you feel the same way. I mean, you probably don't see nearly the media focus on earthquakes in Iran, even though, you know, they're people, families, mothers, fathers, children. We have a harder time relating to people physically and geographically and culturally different from ourselves. And you even see that within the U.S. I was saying that we often see very different coverage of violence against black people versus violence against white people. They're covered very differently in the media. Regardless of the political leanings of that particular program, they tend to cover violence against white people more extensively and more sympathetically and more as a symptomology of some sort of personal pathology versus societal pathology, which is a shame, because that's not the case. There's not two different problems. It's the same problem extended in different ways. Can I make a quick point about Sandy? And I don't want us to get too far off of Sandy, but it is, I think, the largest recorded Atlantic hurricane on record. And I think that probably contributed a lot to the accuracy of the models, because the size of this storm was unprecedented. It would be hard to miss the eastern seaboard if you have a northbound storm that covers half the Atlantic. Obviously, it was going to go towards the area of highest pressure. There was a big static air mass sitting over the Appalachians, and that was obviously the target it was going to head for. The question was whether or not it was going to veer a little further north or a little further south. But regardless, it was going to hit the northern part of the eastern seaboard and have a pretty serious impact given those two large air masses and their velocity relative to each other. But the largest recorded, now not the most damaging, but the largest recorded Atlantic hurricane on record. And it seems like we have hit an awful lot of records, a lot of impressive hurricanes, a lot of catastrophes. If you look at the most costly hurricanes, rank them, let's say the top 50, you'll find that 8 of the top 10 have been from the last 10 years.
What would you imply into that?
Well, it's certainly not climate change, because we all know that's a hoax.
Well, this is exactly what I was asking about. I mean,
talking about that and the election, did you see the heckler? The climate change heckler at the Romney event. Yeah, I mean, that was incredible. So it's some guy.
I haven't. Tell us about it.
He is at a Romney rally, and he holds up his sign saying, "What about climate change?" or something, and sort of says something about very much along the lines of what Concordance says, that this is the biggest Northern Atlantic storm for over 100 years, and he was shouted down, and the crowd just starts chanting "USA, USA," as if this is an appropriate answer to someone who is, I think, very rightly concerned that this is a real change that, particularly in America, they're going to have to start living with it.
Yeah, and I mean, some of the numbers, some of the sort of inflation is no doubt due to increasing development along the seaboard. So if we go back to 1890 or whatever, it's very hard to put valuation on the wooden buildings that they put in. It's an economic metric, unfortunately, for a catastrophe. But even in sort of adjusted numbers, the fact is that the hurricane seasons are getting worse. They're more costly. They're more damaging. Even though our predictions have gotten much more accurate, people are getting lots of advance warning, the systems still aren't in place to do anything about it. People find themselves stranded. They can't afford to leave. They're afraid to leave. If this gets worse, if this is part of a general trend, there's going to have to be more than just science here. There's going to have to be some economic and political will exercise to decide how we respond to these things. If they become an annual thing, do we reconsider building cities in Florida? Building expensive offices and manufacturing facilities and residential development. You know, if every year we can anticipate a $10 billion storm, do we build that into the taxes? Is that part of doing business?
It gets worse than that.
If I may, I think the answer obviously comes from Rick Perry. What is necessary is prayer. Obviously, trite comment, but. Obviously concordance. What you are suggesting is that climate change is a cause of this, and I just wonder whether we are jumping on that bandwagon too quickly, and whether there is actually evidence to support the fact that these weather conditions are as a result of global warming or not.
I agree. Well, I mean, I think this sort of segues into the point I was going to make. What you were saying about Rick Perry praying for an end to the heat wave, which of course resulted in the biggest drought in I think Texan history. Is that right, Concordance?
That's correct. Yeah.
And I forget what it is. I think it's every one of the last 10 years globally has been above average. I mean, there is statistic after statistic like this that show that there's this long-range trend, and for places like Texas, this could be absolutely devastating. In that, how many years of drought do you need to put all of your farmers out of business? Yeah, I would guess that it's 2 or 3. And I remember seeing these interviews with Texan farmers this year that, you know, they had this devastating drought and a bad year before it, and a lot of them were basically ready to go out of business. And at this point, you're faced with the question: do you now actually prop up your farmers with the subsidies, or do you accept, as sort of DPR was suggesting, or that Concordance was suggesting, that this is going to be the way things are going to go from now on, and that you're just going to have to basically give up agriculture in Texas?
Concordance.
I'm not sure that we can say it would go away. It would certainly become very expensive. You know, if the Midwest stopped producing food, half the world would starve. We export so much of it, and it's a big part of our trade balance with the rest of the world. I think long before we're all starving in the streets, it would cripple our economy. That's very much what happened during the Dust Bowl days, if you know any American history, and the Grapes of Wrath period and the Great Depression. Is, you know, the economic collapse even precedes any kind of structural change in food distribution. You know, people aren't going to the grocery store and fighting over the last box of saltines. Their stocks are worthless, or you get this, you know, large migrant population. We're having to pay our farmers, like you say, we have to pay our farmers to keep them from just dumping their crops or dumping their land and turning it into something else. So far, Sandy has an estimated, and I'm just going from the Dr. Wikipedia source, $50 billion. Katrina was $108 billion. And a lot of that damage, I've been to New Orleans a lot recently. A neuroscience meeting there was a few weeks ago. Some of it just will never be rebuilt. That town has a permanent scar in it from that loss. But that $108 billion, that's a pretty staggering amount of money. $50 billion for Sandy, $37 billion for Ike, which was 2008. 2005 was Hurricane Wilma, which cost $30 billion. You know, all of these are within very recent periods of time. Irene last year was $16 billion. I mean, these are financial issues. I'm wondering if we put a lot of thought into how this is going to go. How are we going to continue to pay for this every year?
Again, I have to pause you, Concordance. I'm terribly sorry about this, but I think we are now being joined by our special guest, Philip Moriarty. Philip, welcome to the show.
Hello, how you doing?
We're doing very well. I just wonder if it's possible for you to change your lighting a little bit, because it's all backlit and you look a little bit like a weird silhouette.
You look like a real Moriarty.
That's good. Dark and mysterious. That any better? What if I pull this light across?
Aren't you a physicist? Aren't you supposed to know about light? The path that light takes?
Yeah, but there's certain logistics as regards to cable length, etc., which sort of stim where I want to place the light. That any better?
No.
I think we'll live with it, Phil.
Okay.
First of all, welcome to the show. It's great to have you on, and I also would like to extend a further thank you for the contribution you made to the MSF charity event this year. For those of you who have not seen it, that section of it is on YouTube. Phil spent a great deal of time and effort getting together quite a few scientists from the University of Nottingham, from the physics department and chemistry department, to put together the first hour of the charity event, and I very much appreciate the effort and the work that you put into that.
Thank you. It was a lot of fun, though.
It was. I think I have to say, I think that we were probably a little bit over-ambitious.
Just a bit.
And again, there were technical issues, but hey.
That's how it goes.
There are a number of topics that we have lined up for you, some of which you're aware of, but one which Concordance was eager to start with. So I'm going to hand over to Concordance, and then we'll pick up on the other ones in a few moments' time. Concordance.
Dr. Moriarty, I'm the dinosaur head, by the way.
Philip will do. Philip's more than
Philip?
fine.
Okay, all right, Philip. Philip, we already have a Philip. I'm sorry, we're all full up on Philips.
It's Professor, not Doctor.
Honestly, it doesn't.
Wow. All right, Philip. I saw a video, I think from last year, September of last year, where you were talking off the cuff and off the record on science funding and what the real goal is of university funding. And I thought that was one of the most important messages. I'm reviewing a lot of your videos. What do you think is the purpose of university funding? Where do governments get the bang for their buck?
What a brilliant question to start off with. We've got 5 hours, haven't we, Richard?
Yeah, absolutely.
So, yeah, this is a topic that's really close to my heart. Things have changed dramatically in the UK over the last 5 years or so with regard to how universities are funded. In my view, basically, universities should be there to fund in the large, not exclusively, but in the large, curiosity-driven, blue skies, fundamental research, whatever you want to call it. Because if the market can fund it, sorry, my children are wandering around in the background. Hello, Pat, come here. Sorry about this.
We always like young children on the show.
Well, at least I don't think this is too much of an issue to discuss this with him here. Sorry, Pat. So the main issue is that we have the government really should be focused and funded in universities on stuff that the market won't fund, stuff that's far from market, far from product, far from application. Because if it is close to application, then the market should be funding it. Makes absolute sense economically as well. The fundamental economic rationale for government funding, state funding of university research or basic research anywhere is that that basic research is a public good, or has all the characteristics of a public good in the economist sense. So the problem is, as universities get driven towards more applied, more near-market research, and that is certainly the case in the UK, we are now expected to write down the impact of the socio-economic impact of a research or predict it. And we're also meant to write down its national importance, how it's going to feed into industry, the growth of new industries within 10 to even 50-year timescale. It's remarkable because that's not only eroding basic science, and it's in many cases actually a big issue when it comes to the scientific method, it's also in many cases economically damaging as well.
So let me ask a follow-up. I'm going to say, hypothetically, you have control over the purse strings of a large granting institution. You've got a choice. Now, I'm more in the diagnostics and medical research field. You've got a choice between big science and little science. Let's say you can give a 500,000 pound research grant to 10 individual labs with one PI and a couple of technicians, or you can fund £10 million to some large science project with more ambitious goals on a longer-sighted sort of infrastructure development and something like the LHC. Which of those two do you think is? How do you prioritize those?
There has to be a balance. Of course, it would be great to for the purposes of this show, to argue just pure black and white, but unfortunately, as in many of these cases, it's a gradation, and there are grey areas. Again, as well as the drive towards more applied research, there's also a drive towards funding exactly that type of large group science where you have consortia. I would really like to see the figures. What hasn't been done, to the best of my knowledge, certainly not in the UK, is to compare sort of bang for buck, as you say, for those very large consortia against individual projects. We have something here called responsive mode, which is investigator driven. So it's the small scale stuff you were talking about. You have a group with a principal investigator, maybe a couple of postdocs and a couple of students against something not quite like the LHC, but a big institute with 30 or 40 principal investigators. The responsive mode side of things is getting eroded, getting eaten away, and I think that's very, very dangerous. It's a cliche, but I'm afraid I'm going to drag out the old cliche again. It's graphene. You can point to graphene. That was discovered not by a multi-million pound and multi-PI, principal investigator institute. It was discovered by somebody mucking around with a piece of sellotape. And unfortunately, that type of science is getting squeezed out. And the balance is tipping too far towards the large group science.
So in the U.S. at least, the NIH is the primary funding for medical research. And the last 2 years, there's been an initiative basically for big science only, almost, to the exclusion of a lot of the smaller labs. And I imagine that is an outgrowth of this sort of results-based analysis. There are two, and I hate to say this because it really does work against me, but there are an awful lot of labs out there that are coming up with more questions. They're basically going through the motions of research and doing inconclusive results. They're coming up with interesting hints at, or further study is needed kind of papers, the sort of continuing cycling research, whereas most of the big projects are driven by an administrator who has a sense of the PR value of the research in terms of getting people on board with these very expensive projects, these sort of human genome projects. The local cancer research center, the MD Anderson, which is, I think, the second largest cancer research institution, are doing what they're calling the Moonshot Project, which is a goal to cure 4 cancers by, I forget what the final date, 2030 or 2040. In that sort of accelerated goal-based research rather than the sort of curiosity-based, but hypothesis-driven.
As somebody, I've been involved in quite a large number of and coordinated a few European grants, European networks. One of the main issues with those type of project-based, goal-driven thing is that the proposal is written. I don't know, perhaps it's wrong in the US. It's not like this in the US, but certainly in Europe, one of the major frustrations is that you write the proposal, you put your deliverables down, and those deliverables are set in stone then effectively, unless you've got very intelligent reviewers, for maybe 4 or 5 years hence. That's a really stupid way of doing science, and it's much closer to R&D rather than science, because you lock out alternative pathways. So I'm not, again, it's a balance, but I'm not at all convinced that goal-driven science, because what it turns into is something that's rather removed from science as I see it, where you have to follow your nose, you have to be curiosity-driven, and you don't know what your goals are when you start out. Whereas
I think that's an interesting segue, if I may, to actually, because a lot of people probably are unaware. What is your area of expertise? What are you mainly working on? And there's a supplementary to that. I'll leave that until after the first question.
Okay, sorry, this little man is getting tired, so I'm sure he'll nod off soon. Apologies for this. So my area of research is nanoscience and nanotechnology, but more specifically single atom manipulation, single atom imaging, single atom spectroscopy. The state-of-the-art with the technique now is something I use called atomic force microscopy. The state-of-the-art with that technique is not even single atom resolution. We're down to single bond resolution, breaking bonds. Ultimately, by retirement, what I'd really like to do is to have set up a computer-driven system whereby you can take individual atoms, build up a nanoparticle atom by atom, say that I want, silicon atoms here, maybe I want a boron dopant at position, whatever, 157 or whatever, in that particular lattice. That's really what we're aiming for. So that work's done in ultra-high vacuum, so at pressures comparable to those you get, well, certainly on the surface of the moon, on a better day, maybe in space. And generally at temperatures of at least 77 Kelvin, usually round about 5 Kelvin. So
I hope this sort of like follows on from what Concordance was saying. I apologise if it doesn't, but obviously when you start off in any sort of like work like this, you don't know exactly where it's going to end up and what the benefits are going to be. What do you perceive the benefits of your work potentially being?
Right, so I'll be brutally honest. When I do that work, or the science that I'm involved in, or why I got involved in science at the start, was not because I had some grandiose plans to fix some particular problem. It was because I was ultimately interested in how the universe worked. Not so much on the large scale. I don't know, it's strange. I guess I was not drawn as much to relativity. I was certainly interested in science fiction and all the weird science that sort of falls out of that. And I'm certainly interested in relativity and the ideas of relativity. But what I was more drawn towards was the small scale stuff in quantum mechanics. And it was more about what really brought me into science was the fact that I could ask questions of nature, I could probe nature, and I could try and develop a better understanding, publish that, get it out in the public domain, and also pass that on to the next generation of students, rather than, gotta say it, my goal was not can I cure cancer, because obviously I'm in entirely the wrong field in some respects for attempting to do that.
Our first caller is going to be interesting for you then, but before I bring him in, I'll give you 5 minutes. Explain quantum electrodynamics to us.
Oh, for crying out loud.
The mommy electron and the daddy electron.
Half an 8 on a Sunday evening. Oh, so quantum electrodynamics, right, so Feynman's field. So in terms... Oh, you okay? Come here, sit over here. Sorry about this. My wife,
Phil, I was being somewhat in jest, but if you think you can try and explain it in 5 minutes, then please do so.
I don't know about that. 5 minutes might take. As Feynman said, when he was asked, but it was asked particularly specifically that question by a journalist.
That's why I asked you it.
Yeah, exactly. If you could explain it in 5 minutes, I wouldn't win a Nobel Prize for it. Thanks for the feed, Richard.
Actually, can I just have a quick point on the research funding? I mean, firstly, I think you're entirely right. If we knew what we were doing, we wouldn't call it research. And that does make it inherently difficult to plan. And so ultimately, if you've got some money to spend as a government, you've got to work out what's the best way of actually spending it. And it sort of almost works out, no matter how you do it, you've got to employ people to work out how you're going to spend the money. So there's almost 10 to 20% of the money instantly gets eaten up just in deciding where you're going to put that money.
That's a bit of an overestimate, but yeah, certainly a reasonable amount of it does get eaten up. I'd argue it's probably closer to something like 3 to 5%. I don't usually argue for the research councils, but I'd say it's closer to 3 to 5%.
I was under the impression that ESRF, they were about 10% of. To actually run the funding council was about 10% of the money they manage. I mean, I might be out of touch on that.
Well, the ESRF,
you may be thinking of overhead costs. I don't know if you're thinking strictly of the council money. Yeah. I know at NIH grad, you end up paying 10 to 20% in overhead, which includes the departmental administration, so the sort of lab side administration.
Sure, if you factor that, it's a huge amount. But if I'm just talking about the people on the ground at the research councils, that's nowhere near 20%. No, 10 to 20%. It's closer to a couple of percent, probably at most. But if you factor in the overheads, as Concordance says, then that's a huge amount. That basically doubles here in the UK. That doubles the cost of your grant.
Yeah.
There are a lot of things you can do with. I'm sorry, Thunder. Go ahead.
Okay. The next problem that you come to is no matter what rules you actually set up for how you're going to distribute that money, people are fairly smart and will operate those systems to their best advantage, which is typically not the best way to spend the money. So what tends to happen is as people work out how should we say, abuse the rules, what tends to happen is the bullshit artists tend to get a disproportionate share of the money. Yep. And this leads to the sort of law of unintended consequences, which is where I think very much the funding in the UK is going. And a lot of this sort of seems to be that politicians like to feel like they're doing something. They want some sort of initiative to show how they're going to make Britain great, have centres of excellence, all this sort of thing. Yeah. Whereas I would have, and if I have it right at the moment in the UK, they're trying to more focus the resources in a few select areas, which means that they are sucking those resources from everywhere else, which I think was very much what you were sort of saying about how graphene was discovered. You need that base level of funding everywhere, and that you're going to get diminishing returns if you try and suck all that spare money from everywhere and just put it into a few big projects.
So I agree pretty well with everything you say there, apart from I really don't believe, I think the dynamic is a lot more subtle than the Treasury and government placing a lot of pressure on the research councils to do something. There are people at the research councils, particularly people put in place who took over as chair and chief executive over the last 5 years, who have laid their reputations on the line. And I think they are trying at all. From some perspective, it's very laudable. What they want to do is every comprehensive spending review, every budget, if you want to call it like that, they want to get as much money for science. And what they do is they look at the government policies, they look at what, the sort of ideology de jure of the government is, and they try to align what they're doing with those policies. So even if there isn't direct governmental treasury pressure, there's an indirect drive within the research councils, and that's of course transferred back down to the universities, to match onto specific targets. So it's a very subtle dynamic, but sometimes the research councils, I think, get off the hook far too easily, because they'll argue, our hands are tied, the Treasury told us to do this. And I just don't believe that. And things I've heard over the last couple of years lead me to suspect that, as I say, in many cases, the dynamic is a lot more subtle than that.
I mean, if I have this right, let me have a quick point in concordance. If I remember rightly, in the UK, a lot more of the money just used to go to the universities, who could essentially spend it in a discretionary fashion how they wanted. And that actually had quite a lot of going for it, in that, to a large degree, if you give money to competent people, they generally are fairly good at doing this sort of blue skies research that you were talking about. and you reduce on the management overheads when you're doing that. Anyway, concordance.
You know, I think something that has always bothered me, and I imagine that it discourages a lot of young scientists, is you spend all this time at the bench or, you know, in the applied aspect of the research, and then eventually you get your own faculty spot, and then you sit in an office and you write grant proposals all day. And from that point on, that's basically the business of the lab. You have a small corporation or a small business, if you will, in each lab. And it's being run by the principal investigator who, for the most part, got there based on their scientific qualifications, not necessarily their administrative skills. And so you have a lot of mismanagement or squandering of resource. And I think that's where pharmaceutical companies and my favorite are usually institutes, you know, the Institute for blank myeloma research or whatever it may be, groups like the LHC, where there's a lot of autonomy below the level of the administrators, but the funding is still allocated based on review by other scientists, but administered and selected for by people with more experience and knowledge about how the money should be administered. And that's, I think, one of the biggest weaknesses in principle behind the university research system is you've got people who, through virtue of their ability to do research, are then writing the grant proposals and administering their funding maybe less efficiently.
But who was going to write the grant proposals then, and who was going to administer that funding, if not the people who are directing the group? I think that's a dangerous way to go, where you sort of you section off the administration of the grant, because that's where it's going, and that causes huge problems. You need the flexibility of that funding. Because you will have checks and balances, and there have to be checks and balances. We're publicly funded. I'm certainly not some type of ivory tower academic. But the problem is, what happens is you go into this hyper checks and balances regime, whereby everything has to be accounted for. And that's the autonomy you talk about gets eroded, and that's what's happening so much in UK universities. And so, you know, Thunder said that a significant fraction is getting directed towards administration that is decoupled from the science, and that's a dangerous way to go, I think.
So we have hospitals, for example, that have doctors, and the doctors are the most knowledgeable ones about the applied aspect of medicine. But they don't usually run the hospital. Now, maybe they should. That's an argument we could have. But
those
maybe
this generally aren't doing research.
No. I'm making an analogy here.
Context.
So in the hospital context, you have hospital administrators who understand the basics of the medical requirements. They try to understand what is needed to do good medicine, and they need to be communicating with those doctors. What do you need? Now, this is an ideal ideal world scenario. Imagine a perfect sphere, right? As you physicists like to say. Maybe we need science administrators who can speak the science, understand the objectives, but also have a clearer or more objective point of view.
The problem, Concordance, is that there are maybe 30 people in the UK, maybe 30 that I would trust in terms of sending them a grant proposal, who are close enough to the type of work that I do. And that's not just my field. You can subdivide practically every other scientific activity. Then you've got a real problem, because trying to find those people who are sufficiently aware of the science and the how can I best put this? The requirements in terms of the ability to shift funding from particular sub-project to another sub-project, to have the flexibility to be able to do that. Because if you don't have that flexibility, I'll say it again, it's exactly what's happening at the moment, and is getting worse and worse and worse, is that deliverables are laid down at the start of the project. It becomes not science, it becomes R&D, and it becomes something much closer to the D part of R&D, where you're expected to say, oh, these are my goals. These are what I'm driving for, and this is, this is how I'm going to lay out the budget. The administrator, you bring in a greater administrative overhead, you're going to be constrained more and more. You're not going to be freed up, and that is again problems in terms of scientific research. But more importantly, it has big issues when it comes to the scientific method, because we do not tell an undergraduate student, here's the experiment you want to do, get this result. This is the 10-point step to getting this particular result. Make sure you get this result. We tell them about uncertainty. We tell them about experimental errors. We tell them about following different paths. And so I think arguing to decouple the administrative side, Christ knows I'd love to offload all the administration. From many perspectives that would be great, but it would also be very dangerous, because I know where that money would end up. It would end up essentially in the university and would disappear into a big black hole.
And on that bombshell, on that segue perhaps, of big black holes, I'm going to take our first caller, who's got a really easy, simple question, I think, for you. Alan, welcome to the show.
Thanks. So I actually had a question for Philip. My question was, I think it's a big question within, for a lot of physicists. I know Lawrence, what's his name, Lawrence Krauss has, he wrote a whole book about it, and he's gone into the question a lot, and he's given a lot of talks and stuff like that, and I'm sure you're familiar with him. How can the universe, how can the universe be created from absolutely nothing? You know what I mean? And obviously that's a big question.
I told you it was an easy one for you, Philip.
Yeah, that's the question I have for you.
Thanks for that. Okay, we can have quantum fluctuations. We can borrow from the... How technical can I get, Richard?
Oh, we've got a very sophisticated audience. So
good.
Be as technical as you like.
So the key thing is the Heisenberg uncertainty principle, which we can borrow from. So we can, the particles can pop in and out of existence for certain amounts of time, effectively borrowing energy from, basically from time. We've got two versions of the Heisenberg uncertainty principle. Well, we've got a number, but two primary ones. One, which is the one you've probably heard of, which is the balance between position and momentum in terms of the uncertainty, but we also have an energy versus time uncertainty. So very, very short events can have a large amount of energy associated with them. And of course, if you make that time scale infinitesimally small, you can have vast amounts of energy associated with that. So, there is an aspect there where you can try to understand this. But let's be honest, there are huge numbers of questions out there. We don't... trite thing to say, but we don't have the answers. There was a real problem in our understanding of space-time. We cannot understand this phenomenon, and this has been shown. You get two electrons or two photons, and those electrons and photons can have a characteristic called spin, which you might be familiar with. For electrons, spin is the underlying reason we get magnetism. For photons, spin is basically why we get polarization, why we have different polarization states. But you can couple those electrons or photons, let's say they're two photons together, you can couple them together. Before you make a measurement, you don't know the state of the spin. You send one photon off to one end of the universe, you send another photon off to another end of the universe. You make a measurement, say, on this photon, this one responds instantaneously, not at the speed of light, instantaneously, superluminally.
Spooky action at a distance, right?
Sorry? Spooky action at a distance. And we've been banging our heads against that for decades and decades and decades, and still we don't know that. So once we don't have that fundamental framework sorted out, and I think that means that there are big gaps in our understanding of space-time. There really isn't. You can try and address that. You can think of super dimensions and higher dimensions in terms of string theory. Whether string theory is right or not, it's got a couple to observation, it's got a couple to experiment, and it's not really doing such a great job of that. But to get back to your question, in terms of getting something from nothing, quantum mechanics does suggest that there's a route into that in terms of uncertainty and in terms of the uncertainty principle itself. But beyond that, really, what is the nature of space-time is a huge question. And for the next generation of physicists, and even for this generation of physicists, we've got to get our heads around that. I don't know if that goes anywhere towards addressing your question.
Thunder, I'm sure you would like to comment on how it all began.
I mean, my sort of standard approach to this is that the beginning of the universe is very small and very high energy, which means that you're both in the sort of quantum and sort of relativistic type areas. Both of those are deeply non-intuitive, and it's hard enough to even get a sort of rough understanding of either of these fields. So I think it is a very easy question to ask. It is one that you're not even going to have a chance of understanding, unless you're actually doing things like degrees in physics at universities. And even at that, all you will ever really get is mathematical equations that seem to describe observations. It really is. The quantum world is utterly unintuitive.
Based as it is around complex numbers, which can't, a complex number can't exist in the real world. That's just a fascinating aspect of it, is that you have imaginary numbers. Square root of -1 crops up absolutely everywhere and has to crop up everywhere for quantum theory to make sense. And, that's as abstract as it gets. And yet that does such a great job of explaining how our universe works. I'm just going to...
Well, Philip, if I may...
This little boy is falling asleep. I'm just going to bring him to bed.
Oh, I'm terribly sorry, yes.
Back in a sec.
Okay. I concur and say... Well, let's go back to Thunderfoot. I mean, the mathematical models that Philip was just referring to are just that. They are models to help us understand, but they don't actually explain anything, do they?
Well, they explain things as well as other models that we have, like Newtonian mechanics. The difference is that we have an intuitive feeling for we have an intuitive feel for Newtonian mechanics because our brains are sort of neurologically hardwired to understand it. I expect that if we had to deal with quantum mechanics on a regular basis, like to catch a ball, you had to do quantum calculations, then you would have a fairly intuitive understanding of quantum mechanics as well. But the bottom line is, we don't.
I know that Concordance wants to ask Philip a question. Concordance.
Well, I do, but first I want to make a quick comment. There was a group, I think at MIT, that wrote a program, a game, that you could play where you could interact in a world that had shifting relativistic speed of light changes.
Yeah, so where the speed of light is 20 meters or something.
Right.
Such
right.
that, when you drive your car,
you get these ridiculous Doppler shifts and things contract.
It's Mr. Tompkins, George Gamow, from the 40s, wrote a series of books called Mr. Tompkins in Wonderland, where he played around with fundamental constants like C and Planck's constant. This is a
video game. I think people might be interested to download and see what it would be like in a world where C was something amazingly smaller, or you were able to approach those relativistic speeds. That actually leads into my question for you, Phil.
Well, but just pausing there, Concordance, very quickly. If you send me a link to that when these videos are uploaded onto YouTube, which they are normally done within 48 hours, we will include a link. So if there is a downloadable program where you can play around with that, it will be included in the description. Something to look forward to.
Because that's all physics stuff. It's inherently boring. So I remember last year, it's been about a year, there were neutrinos that were said to be superluminal, that, the headlines were all about Einstein's theory disproved and speed of light not a constant and yada yada. And then it sounds like further studies. So go ahead.
Yeah,
so that was traced all the way back to a problem with the encoding and a problem with the fiber optics. I have very little time for that group. I have very little time. I think they got off the hook very lightly. They should not have gone and created that press furore. if I get that, if our group got anything like that type of result in the lab, you just sit on that and you do the experiment, you talk to other people, you don't go off to the press. Sorry, I'm getting a bit off topic, but that really pissed me off a little bit, because we are driven now, that every result we have to sell it, we have to get it out there, we have to market it. And I really think we're doing science a big disservice by overhyping every result. That's a big result. I'm not saying it's a big result, but because it was potentially such a groundbreaking result, you sit on that for years and you get other groups involved and you second check everything, and third check and fourth check. And the fact that, now it comes back to, an instrumental problem, and the faster than light thing is clearly is not correct. It's bloody embarrassing.
Well, and not only that, it's buried on page 11, right? If you type in superluminal neutrino, you get, 150 hits, all suggesting that this was a real result. No one will know that it was like a fiber optic that wasn't plugged in properly.
Exactly.
Exactly. It never gets retracted. I'm sorry, Thunder, I interrupted you.
To be honest, when I first saw it, and it was parts per 1,000, parts per 10,000, different from light speed. The most obvious explanation at that point, the one that you instantly reach for, is its instrumentation, right? Because it's so bloody small, and it's on. It's a far more likely thing to reach for, and I agree that. Not only do they make themselves look like idiots, but they make the rest of us look like sort of unreliable idiots as well. When you go, oh yeah, Einstein's wrong, and then you come back a week later, loose connection. Sorry.
I think we've moved somewhat off Alan's original question. I think it's only fair if we go back to him to see if he's got any supplementary question. I don't think we've answered your question actually, Alan.
I understand it's like a very hard question, and I guess my follow-up question. I'm not a scientist. My background is not in science at all. In my background, I do social media consulting. So I'll tell you that a little bit of this conversation has been, a little bit over my head. To be completely honest, but I do get the main gist of what you were trying to say. Everyone. And, I guess I wanted to ask this to everyone. Do you think at this point, science, we just haven't gone far enough, or we haven't found the answer to the question yet? We don't know what the answer is yet?
Which question?
How can the universe be created from nothing? My original question.
Well, I think the problem is, Alan, that your question presupposes that there was nothing from which it came, and I'm not even sure that science can say that there was nothing.
Or if there is one universe, or a whole collection of universes that forms the multiverse, and whether we can actually probe those, and beyond the realms of hypermathematics, whether we can actually get some type of evidence for other universes, then we really are straying into the realms of, I hesitate to say this on this particular channel, religion.
Oh, it's quite all right to talk about religion. We love talking about religion. But this is one thing that I find fascinating about the psyche of certain people. There is this enormous unfathomable uncertainties and discoveries that have yet to be made. And I think that it's an exciting journey for people who are obviously going to be much cleverer than I am, because I don't have the first idea about these things. But what I can't understand is the ability for people to so readily accept an explanation which actually provides no answers at all. God did it. How is that satisfying any curiosity at all? I just simply don't understand it. Someone comment.
Well, in the absence of real knowledge, it's I guess a false security, isn't it?
Yeah,
but
what security is it when it's as you say, so false.
But this is
the
sorry,
comfortable
sorry,
delusion. Let me just say, it's the comfortable delusion. That's all there is to it.
exactly.
Philip.
And there's that. There's also this sense that I can turn this over to someone who obviously knows what they're talking about, you know, or who is competent. I like to think that there is a pattern in the world, and that the right people are in charge of the right topics. I have no idea how a router works, but I like to think that someone out there does. To me, it's basically magic. But I have to believe that there's an understandable principle behind it, and these people are just basically thinking of the great IT man in the sky, who makes these things happen. That lets you relax. It gives you an excuse not to worry about something, or not to worry about the fact that you don't understand it. And for people for whom uncertainty is a thing to be feared, it would give you a sense of at least comfort, knowing that, well, somebody knows it. You know,
I think you're right. I think the uncertainty is a factor of the human psychology that.
And I think that's why scientists don't have that. We get excited by uncertainty and the unknown.
Exactly.
And I think that's why there's such a tendency towards non-religiousness or a different kind of spirituality among scientists.
Yeah, indeed.
Alan, I fear, as I say, we didn't answer your question, but
Well,
I think there is no answer. But I'm going to move on. Thank you very much indeed for the call.